This lecture is based on the particle in one-dimensional box. For this, we have introduction and numerical problem on this topic. One-dimensional box, let us consider a case in which a particle is trapped in a rectangular one-dimensional box. The box is restricted and the particle to move along the x-axis between 0 to L. X is equal to 0 and x is equal to L. Suppose the walls of the box are infinitely hard so that the particle does not lose energy when bouncing back from the walls, and the velocity is so low that we can ignore the relativistic consideration. Suppose that the potential energy V of the particle is 0 inside the box but becomes infinite at the walls, and outside, that is V is equal to 0 for if x is greater than 0 and x is less than L. V is equal to infinity for if x is less than 0 or x is greater than L. Under these conditions, particle is set to move in an infinitely deep potential well or an infinitesimal square well. For this, a particle is trapped in a one-dimensional potential box. We can use Schrödinger time independent equation. As we know, Schrödinger time independent equation del square psi by del x square plus 2m e minus b psi by h cross square is equal to 0. For this box, V is equal to 0, and the above equation can be written as del square psi y del x square plus 2m h cross square e psi is equal to 0. Let 2m h cross square e is equal to k square. Then above equation can be written as del square psi by del x square plus k square psi is equal to 0, because let k square is equal to is 2m h cross square into e. Then the solution of this equation, psi x is equal to a sin kx plus b cos kx, where a and b are the unknown constant. The values of a and b are determined by applying boundary conditions. As particle cannot have infinite energy, it neither penetrate the wall nor exist outside the box. That means psi is equal to 0 at x is equal to 0. This one. X is equal to 0, x is equal to L, and the condition is V is equal to 0 where x is less than where x is greater than 0 and x is less than L, and V is equal to infinity where x is less than 0 and x is greater than L. At psi is equal to 0, at x is equal to 0. That means, and for x is equal to 0 at x is equal to L. Sorry, psi is equal to 0 at x is equal to L. Then above equation for A and V, above equation 0 is equal to A sin 0, that means 0, B cos 0 is 1, then B is equal to 0. Thus, B is equal to 0, then the above solution is psi x is equal to A sin kx. At psi is equal to 0, at x is equal to L, then that means 0 is equal to A sin KL, or we can write it as, that means A is not equal to 0. If A is equal to 0, B is already equal to 0, that means psi is equal to 0. Psi is equal to 0 means there is no wave function. If the particle is moving inside the box, that means definitely there is a function. So we cannot consider A is equal to 0. We can consider as sine KL is equal to 0, or we can add KL is equal to 0. KL is equal to n pi. N pi. Or k is equal to n pi by L, where n is equal to 1, 2, 3, and so on. Why we are not choosing n is equal to 0? If n is equal to 0, that means psi is equal to 0 everywhere. It means that the particle is nowhere inside the box, which is impossible. Here we are considering the particle is inside the box. So we cannot consider n is equal to 0. That's why that n is start from 1. Substituting this value, we know k square is equal to 2m e by h cross square, and k is equal to n pi square, means n square pi square by h cross square is equal to 2m, sorry, n square pi square L square is equal to 2m e by h cross square, or we can write it as E is equal to n square h square by 8 ml square, as h cross is equal to h upon 2 pi. So h cross square is equal to h square by 4 pi square. We put here we have n square pi square by L square 2me. H cross is h square by 4 pi square. Pi square to pi square cancel out. That 4 becomes to 8. That means 8 ml square h square n square. That En is equal to n square h square, n is equal to 1, 2, 3, and so on. Therefore, it is clear from the above equation that inside an infinitely deep potential well, the particle can not have an arbitrary energy, but can have only certain discrete energy corresponding to n is equal to 1, 2, 3, and so on. Each permitted energy is called eigenvalue of the particle and constitutes the energy level of the system, and the integer n that specifies the energy level is called quantum number. The wave function psi corresponding to each eigenvalue are called eigenfunction. Okay, so this is the energy formula for the one dimension potential box, where n is the number of energy level, h is a Planck constant, m is the mass of the particle, and L is the length of the box. Okay, on the basis of this, we can calculate the energy of a particle. So here we have a numerical. Find the energy of an electron moving in one dimension in an infinitely high potential box of width 1 angstrom, where the mass of the electron is m is 9.11 into 10 to the power minus 31 kg, and h is 6.63 into 10 to the power minus 34 joule second. We have formula E is equal to n square h square by 8 ml square. Find the energy of an electron moving in one dimension in an infinitesimally high potential box of width 1 angstrom. M is equal to 9.11 and H is this. So here we don't have the number of the states, so we are consider least energy state N is equal to 1. Then our formula can be written as E is equal to H square 8 ml square. Here H is 6.63 into 10 to the power minus 34. M is 9.11 into 10 to the power minus 31, and L length is what? The potential box of width 1 angstrom, means 1 angstrom, that comes to 10 to the power minus 10 meter. Here we are using, this one is 6.63 into 10 to the power minus 34 joule second, and this one is kg. So here we also convert this angstrom into meter, that is 10 to the power minus 10 meter. So the energy is h square, means 6.63 into 10 to the power minus 34 whole square divided by 8 into m is 9.11 into 10 to the power minus 31 into length of the box is 10 to the power minus 10 to the power minus 10 ka whole square. Here we have 6.63 into 10 to the power minus 4 ka whole square, or that means that comes to minus 68, and minus 31 and minus 20, that comes to minus 51. 51 plus is 51, that means minus 17. Okay, minus 17 points, that comes to 6 point. When we calculate these value, that comes to 6.03 into 10 to the power minus 18 joule. For the energy, we can also convert this value from joule to electron volt. For this, we have to do divide by 1.6 into 10 to the power minus 19 electron volt. Comes to E is equal to 6.03 into 10 to the power minus 18 divide by 1.6 into 10 to the power minus 19 electron volt, and that comes to 37.69. This is the answer of the position. The energy of that particle in ground in first energy level is 37.69 electron volt. Okay, so these are the references.